So this is the Unit 2 Polynomials, Lesson 2.3, Introduction to Polynomials. So when you're doing this lesson, you're going to have two essential questions. When might it be useful to combine polynomials through basic operations? And when a polynomial is rewritten into factor form, what facts do you know about the polynomials that you didn't know before? That's kind of confusing the way it's written. So that second one, I believe it's a misprint. It says, when a polynomial is rewritten into factor form, what facts do you know about polynomials that you didn't know before? What don't you know? So here are the objectives for the lesson. You can define and identify a monomial and a polynomial. You can order and name a polynomial, so you'll have to rewrite them in order. You can write a polynomial in its standard form. Identify the leading coefficient. So one of the first words that you need to know is polynomial, and if we break that word down, it starts with the word poly. Poly means many. So this is an expression with many terms, or basically more than one term. A monomial is a number, variable, or the product with non-fractional exponents. It's basically just one term as long as the exponents are not fractions or negatives, because a negative does matter. So here are some examples. 8y, so it could be just a constant, that's a monomial, it's just one term, or 8y, the coefficient with a variable, or 8y squared, so it could have an exponent on it. But here are some non-examples. 4 to the negative 6th, because if you have it to the negative 6th power, remember you can change it to 1 over 4 to the 6th. It makes a fraction. Degrees. Degree is the highest exponent of the monomial. So for each term, what is the highest exponent that you see? The way we name our monomials and our polynomials is based on the degree, so the highest exponent. So if you don't have any if you don't have any variables at all, just a constant, then you just call it a constant. So no variables at all. If there is a variable, like in the second example, that's my pen there. In the second example here, we have an x on that negative 4x. When you see a variable but you don't see its exponent, you do assume that it's a 1. It's like that little phantom 1 that's up in the air. Let me see if I write that in. Right. So anything to the first degree is called a linear equation. That's what you had in Algebra 1A, is all linear equations. We didn't have any exponents higher than 1. When your highest exponent in the polynomial on 2, is my mouse going to show up? The highest exponent on the next polynomial is 2, this number right here. Oops, can't really see that real good. Let me try rewriting that. So in our third example, we have a polynomial that has 1, 2, 3 terms in it. 2 of those terms have variables in it. The first and the second term, there is a variable in each. But the highest degree, which means the term with the highest exponent, is 2. So we would say the degree of this polynomial is a quadratic. So 2 stands for quadratic. This is the hardest one for students to remember, because most people, when you think of quad, you think of like a four-wheeler. So you think it's supposed to be 4. Whatever you need to do to remember that quad means 2. It's quadratic. On the next example, we have a 2-term expression. What's the highest exponent that you see in that expression? 3. Okay. Because the highest exponent is 3, this is called a cubic. If you remember when we were trying to solve cube or a volume, you had to multiply 3 things together. That's where that cube comes into place, like in length, width, and height. So that's where the word cube comes from, if it's to the 3rd power. If our highest exponent is 4, or the highest is the 4th power, then this is called a quartic. The word quartic has the word quart in it. which you might have heard there's 4 quarts in a gallon. There are 4 quarts in a gallon. So this could help you remember that when you see the highest exponent is 4, it's called a quartic. So starting with quadratic, they all end in that IC, IC, IC. So the prefix before that is to help you remember how many terms there are, or the highest degree there are. The next example, to the 5th power, is called a quintic. You probably have heard the lady that had quintuplets. That means she had 5 babies. Yeah. And the last example there, 6th or higher. When your highest exponent is 6 or higher, then you just start saying 6th, 7th, 8th, 9th. So only the ones 0 through 5 have special names. After that, you just say to the whatever power. So a degree of a monomial, that means just one term, is the sum of the exponents of the variables. So let's take a look at this example here. We have 8xy. So if we break it down, 8xy is made up of 3 parts. We have a coefficient of 8. You can write that in on your box there. Oh, I'm sorry. Back that up. They want us to write down the degrees. Okay, so if we split up that 8xy is made up of an 8, an x, and a y. What is the exponent of the 8? If you don't see it, it is 1. So the degree of the 8 is 1. The degree of that x would also then be 1. And the degree of the y would also be 1. So that means the degree of the monomial would be 3. So that in question 12, the degree of the monomial 8xy is 3. So let's try a couple more examples here. It wants to know what the degree of the monomial -7 to the y to the 4th z is equal to. Go ahead and take a minute, see if you can figure it out, and then we'll go over the answer. So if you split up the -7 y to the 4th z, it would be like saying -7 to the what power?
1.
To the 1. Y to the 4th is already written. And then it would be z to the what power?
1.
1. All right. So add up those exponents, and that'll calculate your degree. 1 plus 4 plus 1 is equal to 6. So you would say it's the 6th degree. And if anything higher than 5 is to the whatever th. You can spell out the word 6th, by the way, too. So we found the degree is 6, and it says then find the degree of the monomial. So the other one is the 11. Well, what's the exponent on the 11?
1.
1. So that means it's just to the first power, so this is called a constant. Okay, so I told you something wrong, and we need to go back and fix it. I thought something didn't look right. I know that when I have a number by itself with no variables, it's called a constant. So here's what I did wrong, folks. When you write your degrees, only write the degrees of your variables. Coefficients don't get a degree. So what I did wrong here is I should not have put a 1 on that 8. So coefficients don't get a degree. Or constants also don't get a degree. If you have a number by itself, it doesn't get a degree. So that degree of 8, you put 0 there. same with on question, so this right here on question, or up the top on our example, that shouldn't be to the degree of 3, it should only be a degree of 2. Everything else is right. So let's fix our problem 13. That -7 does not get a degree. Only variables get degrees. So then on our first example, that should be to the 5th degree. So if you look back on your chart, 5th is called
Something, Quinn, something.
yeah, a quintic. Remember the lady had quintuplets? Quintic, quintic. The 11, it's just a number, has no variables, so there's no degrees. So 0. And therefore it's a constant. So that does follow your chart. Sorry for that mistake. Alright, so let's see if we can calculate the degree of these monomials here. Remember that a number by itself or a coefficient or a constant does not get a degree, only the variables. That first question there, that appears to be a typo because that 3 should be up in the air. So this one is 3y to the 3rd power. I don't know why that 3 is down low like that. So see if you can do this page on your own, and then we'll go over the answers. So let's check your work. On the first example, our degree of our only variable is 3. So we have only to the 3rd degree, and 3rd degree is called a cubic.
Oh, I did it wrong.
It is 3rd degree. It is asking for the degree, so it is the 3rd degree. But then if you need to name it later, so I guess if this had a column that said name, sorry, I can't write real well with this, you would call it cubic. But as far as the degree, yeah, you're right. It's the 3rd degree. Right, in the next example, we have 3 variables in the example. The first variable has to the 2nd power, the first variable is to the 2nd power, the second variable is to the 3rd, and the last variable is to the 1st power. If you add them up, that would be 6 of them all together, so it would be to the 6th degree. And its name would also be 6th. In the last example, there's no variables. So there's, you would say it's to the 0 degree. If you were to name it, it would be called a constant. It's not easy writing with a stylus, sorry for the handwriting. So a polynomial, unlike a monomial, means that it's the sum or difference of monomials. Or basically it's an expression with more than one term. So here are some examples. 2x minus 7. Do you see the 2 monomials in the expression? The monomials are the terms. So 2x is one term and -7 is the other term. If they were by themselves, we would call them monomial, but because there's more than one, it's called a polynomial. (5x squared plus 2x minus 8). How many terms are in that expression?
3.
3. Good. So these are all examples of polynomials. You can see that the terms have the plus and minus in each term. So that's why they say it's the sum or the difference of monomials. So the number of terms in expression also gives it the second part of the polynomial's name. So you count the number of terms. If you only have one term, it's called a monomial. So before we were calling them first degree, second degree, whatever, monomial. But if there's more than one term, then you would also calculate the degree, find the highest degree, and then call it a binomial if there's two. Bi, like as in bicycle, 2 wheels. 3 terms is trinomial, like a tricycle has 3 wheels. But anything higher than 3, we just simply call a polynomial. They're all polynomials, but we just call anything above 3 poly. So classifying polynomials. To classify them, you first have to find the greatest degree of the term. So you find the term with the highest exponents to find out the highest degree, plus the lesser degree term equals, or plus the least degree term. So just a second, we'll write those down. Alright, so what you're essentially doing is writing these in standard form. Look at our example, 2x minus 3 plus 8x to the second power. Which one of those has the highest exponent on the variables?
8x2.
Yeah, the 8x2. So we'd write 8x to the second power here. And then you go down from there. The next one that has a variable is the 2x. That would be to the first power. And then the one with the least degree would be always your constant, which is in this case is -3. I think it's a little confusing that they put these little plus signs here. Yeah, that's a little confusing. This is a positive 2x. So if we were to rewrite this into standard form, you would write 8x squared plus 2x minus 3. Notice when we rewrote it, the 2x, before it was in front, and so you didn't see a sign there, but we know it's positive. If you ever have a term that's not the first term in expression, if it's positive, you have to write that positive sign in front of it. If it's what's called the leading coefficient, or the first term in the expression, that's the only term that you don't have to write the positive sign. So when we wrote the 8x squared here, we didn't write the plus sign in front of it. Alright, circle the best name for this polynomial based on its degree. The highest exponent of that first term is what?
Oh, the first term?
Mm-hmm.
It's cubic.
It's a 2. Check your chart.
Yeah.
Go back and look at your chart to see what the degree of 2 is called.
Oh. Quadratic.
Yeah, it's called a quadratic. So circle quadratic. Now, how many terms are there?
3.
3 terms. So would you call it a monomial, a binomial, or trinomial?
That's trinomial.
Trinomial. Tri means 3. So the full name for this polynomial is called a quadratic trinomial. Alright, so let's take practice some more of these. So step 1, find the degree of each term. Step 2, determine which term has the highest degree, and then finally state what the answer is, the degree number of terms. Alright, so in step 1, if we look at the first term, the highest degree is 3. In the second term, the highest degree is 1. And the last term is a constant, so it doesn't get a degree. So the highest degree is the 3, or the 5x to the third is the highest degree, which is the 3. So it says step 3, state the answer as the degree number of terms. Okay, so the step 3, let's cross that out and just say what's its name, because that's what that's asking us to do. What's the name of this polynomial? So the highest degree is 3. which, so if it's 3, we call it cubic. And because there's 3 terms, we call it a cubic trinomial. So that's the name of this polynomial. Right. Second question, step 1, find the degree of each term. What's the degree of the first term? Go ahead. 6. The degree of the second term is?
5.
And the degree of the third term is?
0.
0. So our highest degree is the 6. Right? So the name of this expression is called a 6th degree.
6th degree.
And what's the second part of the name?
Trinomial.
Trinomial. Sixth-degree trinomial. So when you name a polynomial, you have to give it, it's a 2-part name. The first part is the degree name, the second part is the number of terms that's located in the expression. Go ahead and do the next one on your own and then check it with the recording. Okay, let's check your work. So the first term has 3, the exponent, highest exponent is 3, 2, 1, and 0, so the highest degree is 3, and therefore its name is a cubic polynomial. Looks like you're right. So standard form of an expression. Standard form of a polynomial is a list of the monomials in order from largest to smallest degree. The leading coefficient of the term with the leading coefficient is the coefficient that's basically first. It's the one with the highest degree, the largest degree. So let's look at standard form. Here we have an expression that is not in standard form. Let's rewrite it in the new order. Our highest degree is the 3, so you would write negative 5x to the third. The next term, the next highest degree, would be positive 3x. And the final term with the lowest degree is plus 7. So because the highest degree is 3, the name based on its degree is cubic. And the name based on the number of terms is trinomial. And you just put it together to come up with the full name, cubic trinomial. So our next example. The correct order, the highest degree is x to the third, so we have x to the third plus 7x squared minus 4x minus 1. The name based on the degree is cubic. Good. And the name based on the number of terms is has more than 3. Anything more than 3 is called a polynomial. So the full name is cubic polynomial. Last example. Write it in order. Negative 8x to the fifth plus 6x plus 3. Make sure you use those plus and minus signs you did there on yours. The name based on the degree is to the 5th. Remember the lady had 5 babies, so it's quintic. And there's 3 terms, so it's called a trinomial. So the full name is quintic trinomial. So in summary, a polynomial is named by the highest degree or the highest exponent on the term. You have constant, linear, quadratic, cubic, quartic, quintic, and then 6th, 7th, 8th, and beyond. And the second part of the name is the number of terms it has. Monomial, binomial, trinomial, all the way up to polynomial for everything higher than that. Alright, turn to your guided practice packet and do problems just 1 through 15 of this packet.